We have a special treat this morning, which is John no, I said it correctly earlier, Cangialosi. That's right. Cangialosi, good, thank you. Who is Diane Chapin's son-in-law, Courtney's husband, right, who has agreed to be with us this morning to speak about an area where he has some expertise, global climate change and the role of the National Hurricane Center. When the group, the mission trip, the 30 of us went down to Fort Myers to help with hurricane cleanup, John sent this fascinating, very informative video to the group about the effects of Hurricane Ian and talked about the uniqueness of that hurricane and the area where we were. And it was very informative for us who were there. And he sent this lovely thank you to us. And we did all of that on video. So grateful for that. Anyway, that's just a little preview. But we're going to start with a word of prayer, and then I'll introduce John and we'll get started. Holy One, we come before you this morning in the midst of turmoil, in the midst of everything that is swirling around us in the world. And we ask that you center us to be together as community, as your community, to learn how we can be your peace, your presence, your voice in our tumultuous world. And we pray, Lord, that as we learn now more about hurricanes and climate change and things that are swirling around us from John, that you would open our hearts and minds to discover what it is we need to know in order to be your faithful followers. Send your spirit now into our midst. In Christ's name we pray. Amen. John Cangialosi is a senior hurricane specialist at NOAA's National Hurricane Center in Miami. He received his BS in meteorology and mathematics from the University of Miami in 2002. He received his Master of Science degree in meteorology and physical oceanography from the University of Miami's Rosenstiel School of Meteorology and Atmospheric Sciences in 2004. John was the senior research associate at the University of Miami from 2004 to 2005, and he received the Dean's Prize for the best master thesis at the University of Miami's Rosenstiel School of Meteorology. He received the most outstanding graduate at the master degree level. So well decorated. Began at NOAA in 2005 as meteorologist intern with the Tropical Analysis Forecast branch, and then became a hurricane specialist in 2009, was promoted to senior hurricane specialist in 2018. And I'm sure he'll talk more about what this position involves, but part of it is the issuance of track intensity and wind radii forecasts, as well as associated watches and warnings for tropical cyclones in the Atlantic and Eastern North Pacific Oceans. He's presented at several meteorological conferences, and he's an instructor for several courses. He works with the Hurricane Hunters, and I have a connection to the Hurricane Hunters, which is one of my brother-in-law's former girlfriend was a hurricane hunter in Biloxi, Mississippi, Devon. And so I know some of the hair-raising work that they do. John has received a local, regional, and national Isaac Klein awards during his time as a hurricane specialist. So something different for us today, and something from which I know we will all glean insight and wisdom. So, John, thank you so much for being with us this morning, and I'm going to turn it over to you.
Yeah, no, my pleasure to be with you. And hello, Diane, to my mother-in-law in the room. And thanks for the kind introduction. I really appreciate it. I set an alarm for 10:35 because I want to make sure there's time for questions. And if there's anything I didn't cover, just feel free to ask. I really want you to get the most out of this as possible. So I did have a slide here about me, but you just read everything that's really on here, so I won't go over it again. But I do want to say, in addition to all of this, most importantly, I'm Diane Chapin's son-in-law. And that's so hello to her there. So I wanted to cover a little bit about what I was going to talk about in this presentation. So for starters, I want to give you an introduction to the National Hurricane Center. I'm sure most of you don't know a lot about what we do. So I want to give you some ground about, what we cover, the area of jurisdiction, and how this kind of works on a global sense when it's related to hurricanes. Then we'll spend some time talking about hurricane history, climatology, hazards, how it hurts people, unfortunately, and where we are today with our current state of forecasting and predictions. And then I'll close out talking about the outlook for the future, where we stand with global climate change, what the consensus view among scientists is in that regard, especially as it relates to hurricanes, which is really what I'm an expert in here. So I have to get a little science out of the way because it's really going to help you kind of understand really what I'm talking about. So at the National Hurricane Center, our job is to predict what's called tropical cyclones. It's probably a term you haven't heard very much. It's a science term that really, it sort of encounters or includes tropical depressions, tropical storms, and hurricanes. So here's the criteria needed for it to be a tropical cyclone. They have to be large and long-lived low-pressure systems. Hurricanes don't come and go in a day or hours. They have to last days to weeks for us to really be interested in them. They form over very warm water, generally around 80 degrees Fahrenheit or warmer. They do not have cold fronts and warm fronts. So unlike things in the mid-latitudes where you get air mass changes, and that's really what promotes tornadoes and severe weather, hurricanes like very uniform air masses. So just essentially warm and moist and nothing else. They produce organized thunderstorm activity, especially in close to where they're located, their center, and they have to have a closed and well-organized circulation. So from a science perspective, all of this criteria needs to be met for us to call it a tropical cyclone. And why this is so important is that the records need to be stable over years and decades so that we can compare trends over time. And I'm going to talk about those trends a little bit later on. All right, so let's imagine for a second all of that criteria is met. Then we classify the systems by their intensity. So if that definition is met, but the winds are light, less than 39 miles an hour, it's called a tropical depression. If the winds are moderate, between 39 and 73 miles an hour, it's called a tropical storm. And if winds reach this 74 mile an hour zone, and this is sustained, by the way, not gusts, sustained 1 minute winds, it is then called a hurricane. And you might have heard the nomenclature of hurricanes called the Saffir-Simpson hurricane wind scale. So Saffir was a meteorologist down here in South Florida and an engineer, and Simpson was the director of the Hurricane Center. And they came up with this scale decades ago in the 1960s, and it still stands today. So major hurricanes are category 3, 4s, and 5s on that scale, where the maximum wind speeds need to be at least 111 miles an hour or greater. And when you guys were down in Fort Myers, Ian, the maximum winds were closer to 150 miles an hour in that particular storm. All right, now hurricanes are not unique to our part of the world. What I want you to look at is a global activity. Now, here we are in the Atlantic, this is North America here. And you can see the tracks across the Atlantic basin. They're all spread out across the basin. I'll talk about why. There's activity that occurs across the Pacific, the Eastern Pacific, the Western Pacific, and tropical cyclone activity that happens in the Southern Hemisphere, near Australia, in the Indian Ocean, and in the South Pacific Ocean. You might notice there's a couple places in the tropics where we don't get tropical cyclone activity, and that's around South America. And we'll talk about why. It has everything to do with ocean currents. Now, you might find this interesting, and you might have come across this in your readings in the past, or just kind of heard it. What's a hurricane? What's a typhoon? What's a cyclone? What are all these names? They're all the same exact thing. I don't know if you knew that. On our part of the world, we call them hurricanes. In the Western Pacific, they call them typhoons. In the Southern Hemisphere, near Australia and the Indian Ocean, they call them cyclones. It's just how these things were born through regional sort of definitions and how they came about. but they're the same exact scientific animal. So in the science community, we just call them tropical cyclones for simplicity, because that's really their scientific name. And they're just given regional names to make people sort of remember and sort of understand. It's really history. It's definitely not science where these names came about. Okay, so I want to show you where the National Hurricane Center fits in globally. So there are 7 hurricane centers around the world, and they're listed here. So the hurricane center that I take part in, I'm going to show you all about today, is the one in Miami, and it covers the area of the entire Atlantic basin. So from Africa and Europe all the way to the United States and Mexico and Central America, as well as the Pacific Ocean to this longitude mark 140 west. So all of this zone is the National Hurricane Center's area of responsibility. The smaller zone here over the Central Pacific is done by our colleagues in Hawaii that covers the vicinity of the Central Pacific around that island chain. In the Western Pacific, there's a hurricane center in Tokyo, and then you can see the others that are listed here on the map. But we're really only one of 7 places across the world. And probably the neatest thing for me at the Hurricane Center is the real international feel. I know people in all of these hurricane centers and coordinate with them fairly regularly. So it's really neat just to have these connections on a global scale. But here's the Hurricane Center. As you just heard, it's in Miami, Florida. It's about 10 miles west of downtown Miami on the Florida International University campus. So here's our facility. It's not very big to be given a title of National Hurricane Center. In fact, it's bigger than national. It's sort of, a quarter of the world hurricane center, if you will. And we only have about 60 employees in the entire facility. And the ones that do the hurricane forecasting specifically, there's only 10 of us. So I'm one of the 10 that actually does the hurricane forecasting specifically. Now, I did state our mission down here at the bottom, but I'll talk more about that. But the bottom line is our main purpose is to save lives, mitigate property loss, and improve economic efficiency by trying to get the forecast as right as possible, issue the more appropriate watches and warnings, and also something I'm passionate about is try to educate people before the storms come so that they make good decisions for themselves. Now, I wanted to go back in time a little bit with history. Why is it important that we forecast hurricanes? Well, the National Hurricane Center didn't come about until the 1950s. In fact, didn't really systematically forecast hurricanes until the 1960s. But the reality is hurricanes have been happening for a long time, as long as we possibly know. And the most destructive and deadly hurricane in history still stands as the 1900 Galveston hurricane, when people were given essentially no warning that the hurricane was coming. Meteorologists back then had almost no tools to work with, and they really relied on just sort of pressure reads and really what was happening now. They couldn't make much predictions. Unfortunately, 8,000 people lost their lives in the Galveston hurricane. Most of them drowned in the storm surge flooding. And again, it still stands as the deadliest hurricane to date. In 1935, a Category 5 hurricane struck the Middle Florida Keys. At the time, there was a railroad being built to connect Miami to Key West. It was supposed to be revolutionary at the time, and it was about 2/3 of the way under construction when this hurricane came. Again, essentially no warning at the time for this hurricane. About 500 people perished. The railroad was completely destroyed and has never been tried again since that date. If you're kind of interested in that specific hurricane, I encourage you to check out the movie Key Largo that was in the late 1940s. It gives a really nice sort of documentary and sort of people feel about what took place during that storm. All right, so our goal is to save lives. What does this mean? How do we save lives at the Hurricane Center? Well, we work really closely with FEMA and different government agencies to issue evacuations in hopes to get people out of harm's way. Now, this picture of this house, I'm just showing this as an illustration, was taken before Hurricane Katrina made landfall. This is in southern Mississippi in the town of Waveland. If you can't tell by the name, it is right on the coast. So this picture, again, beautiful home, nice green grass. This is what that property looked like after the storm moved through. And you can see the home's gone. If you look closer, you'll see that all of the front lawn is burnt up due to saltwater penetration, meaning the ocean made it there due to the storm surge flooding. And the things that are stronger than the homes are like these large oak trees that have really strong roots. And we learn so much from post-analysis all the time. So fortunately, these people did evacuate, and did the right thing. But unfortunately, there are many circumstances, including Hurricane Ian last year, where that just did not happen, unfortunately. So I want to just do a quick exercise with you guys. You can, if you're not muted, you can scream out your answer, or we can just pause. So when you think of a hurricane, when you sort of picture it in your head, I don't want you to picture a satellite image like this. When you just sort of picture being in a hurricane, I'm curious what exactly comes to your heads. I know, in the DC area, hurricanes aren't really your problem. You get on the periphery of things sometimes. But what do you think of when you think of a hurricane, especially if you live in locations further south? Anybody? If you're not muted, feel free to scream up.
Wind and rain.
High wind.
Okay. Yeah. So most people think of the high winds. Most people think of that. That's sort of intuitive. Hurricanes do produce a lot of wind. I already told you major hurricanes have at least 111 mile an hour sustained 1 minute average winds, which means the gusts could get closer to 200 miles an hour on a second by second basis. But the reality is what kills people, unfortunately, in hurricanes is mostly water. About 90% of people lose their lives in hurricanes actually drown. That's the reality. So even though the emphasis has always been on wind, the reality is the flooding rains from the storm surge flooding coming in off the coastline and the rain-induced floods is really what's causing the biggest problem. And if you kind of go back to 2017 in your heads and you kind of remember this was a big news story at the time, Hurricane Harvey hit Texas and just sat around that area. Some spots in eastern Texas near the Louisiana line got about 60 inches of rain in 3 or 4 days. So for that geographical area, that's about a year's worth of rain in 3 days. And for the DC area, that's like a year and a half worth of rain in 3 days. The point is, even areas that can see that kind of rain, it has nowhere to go. And again, it was so destructive due to the rain, even though most of the time it was pretty weak when it was sort of sitting around that area. And it's been busy lately. The Hurricane Center has been a fun and stressful place to work. It's been fun scientifically. It's been, energetic. There's been a lot of things going on, but it's also been very tolling. So since 2017, I'm going to just sort of write on this for a minute. We have seen 20 hurricanes hit the United States. So that's not normal. We're going to talk about why. So don't jump to climate change because that's not really the right answer. We'll talk about some of these reasons. So 20 hurricanes have hit the United States since 2017. That is more than we've seen in really big span here. What is that, 50 years-ish? From 1963 to 2016. So what gives? During the last 6 years, the United States, just from hurricanes, has suffered $455 billion in damage. Of the 20 hurricanes that hit the U.S., 16 of them have caused at least $1 billion in damage individually. And 8 of them have caused at least $10 billion of damage individually, which is because this is so economically tolling, and this is just one natural disaster. This doesn't include floods from other events. The administration continues to fund our work and continues to try to improve forecasting to try to make all of this relevant and to try to protect people and property. So last year, as I mentioned, and as Emily mentioned, your community went down to Fort Myers and specifically spent time in Fort Myers Beach, which was ground zero during Hurricane Ian. Now, I took these pictures myself. I was down there not on work-related duty. I was down there because my parents lived there and my grandma lives there and uncles. And this was completely destructive for that area. So where I took these pictures, I actually did a little work, even though I wasn't told to. We measured high water marks. And this is essentially like moldy mildew lines that indicate how high the water got in these areas. And the water got about 15 feet high. Now, we're not talking about sea level rise. We are talking about how high the ocean got into this area that was being pushed by the winds. And of course, the infrastructure can't handle that. So you could see the damage that you see here, boats tossed, homes destroyed. This was the most destructive hurricane in Florida's history, and that's a long history when it comes to hurricanes. Fortunately, Fort Myers in South Florida has bounced back nicely. A lot of this area is being cleaned up. The economy is coming back. Still has a ways to go, but it's good to see that it's not being held down for too long. So I want to talk a little bit about climatology, because when we look forward, you got to look back before you could look forward. It's really important putting everything in context. So in the Atlantic, our records go back to 1851. Nobody was around, of course, back then that's around today. But the reality is records were kept in the basin going back that far, which is really great, which draws parallels. Now, you might say that gives us a long time to look at records. True. The problem is the technology has changed so much that we're really not looking apples to apples if we go back to 1851. Satellites did not come aboard until the 1960s. So if you're going to compare records and look forward, the reliable records generally take place in the late 60s. We typically start them at 1970 when applications of satellites were used universally. In the Pacific Ocean, the records don't go back as far, only to 1949. Now, each one of the red lines that you see here correspond to a track that a tropical cyclone has taken. And if you forgot what tropical cyclone is, it's a tropical depression, tropical storm, or hurricane. It does not differentiate here. So you can see if you look in the Atlantic basin, they go just about everywhere, all across the deep tropics, across the subtropics, and even into the mid-latitudes. And if you didn't know, Canada, Atlantic Canada, gets hit by a fair amount of hurricanes. In fact, they got 2 systems this year in Atlantic Canada. And that's a little surprising. And Canada actually has organically rooted and developed a small branch there in Halifax called the Central Pacific, the Canadian Hurricane Center, which is not an official hurricane center, but we work closely with them to help them educate and make forecasts for their specific zones. Now, you'll notice that it looks really different, right? Down here on the Pacific side, there's almost no hurricanes near Southern California, where we get hurricanes in Canada up this way. And if you just sort of look at the longitudes and the latitudes, this doesn't make any sense. Well, this has everything to do with ocean currents. So in the Atlantic, there's the Gulf Stream current that spreads warm water from the Bahamas and Florida up toward New England in the summer months. So the hurricanes can hold together to some degree as they gain a lot of latitude. But that doesn't happen in the Pacific. There's a cold water current that streams southward from Alaska. So there's cool waters in place like all the time in Southern California. And for that matter, even across the northern Baja Peninsula. So as storms get to about this mark, they just quickly fizzle out due to those cool waters. Now, I want to show you what time of year we have to worry about hurricanes. It's essentially half the year. The official season starts May 15th and it ends November 30th. We always throw like some sort of party here on December 1st because we're done. And usually the season winds down kind of like middle of November. So we're getting close. Now, if you look at this chart here, whether you look at the red, which is hurricanes and tropical storms together, or the yellow, which is just the stronger variety of hurricanes, you'll see a really pronounced sharp peak. That peak of the hurricane center, of the hurricane season, is right there at September 12th, which is exactly, Diane, that's Courtney's birthday, September 12th. It is the peak of the hurricane season. I am never, ever off. And in fact, I'm usually extraordinarily busy. So it's just the way it is. Now, the real meat of the season is 3 months. So it's August, September, and October. And then we really start to wind down. So 3 months of the year, we got to be really on guard, but we still get some activity the other months of the year. And I want to show you where the activity typically is on a month-by-month basis. So in the month of June, it's generally close to the U.S., typically along the Gulf Coast and near Florida and the Southeast. By July, the activity starts to spread across the Caribbean. By August and September, it's essentially everywhere across the basin. This is where really our eyes are opened up. This is where we get multiple storms at once. By October, this time of year, the activity shifts back to the western half of the basin. And then by November, things really wind down. So living down here in South Florida, you can see we don't really get a break down here. Essentially from June all the way through October, we're on guard for hurricanes. And that's true for most of the Gulf Coast as well. All right, so I want to talk a little bit about how we make predictions. So how do we predict the weather? How do we track hurricanes? So first, how do we track things? What helps us with our weather analysis? Well, we use a variety of things that I'm going to show you here on the screen, but I'll sort of take it one by one. The first thing we actually do at 122 locations across the United States is launch weather balloons. That might seem like a sort of a fun exercise, and it is. It's typically when you get into NOAA, it's your very first job is to launch weather balloons. And they're launched, as I said, across the United States, also globally. And you might say, well, why would you do this? Well, we know a lot about what's happening down here at the ground, which is great. We have observations at airports. We have observations at various locations, buoys out at sea, but we don't have a lot of observations up in the air. And almost all of the weather that takes place and generates doesn't happen here at the ground. It happens at the cloud level. So we got to get out there and sample it. Now, satellites help us to some degree, but the specific observations help us more. And this is an example of one being released right at the back of our facility. Satellites are our number one tool, far and away. Satellites we call our eyes at the Hurricane Center, especially for us looking on the large scale, because we're trying to see what's happening over the oceans. There's not a lot of observations over the oceans. There's buoys and there's some transatlantic ships, but you can't rely on just those spot observations. The satellites today are so impressive. I just want to share this. I got to see them launch at Cape Canaveral a few years ago. And they've changed so much over my career. There's two satellites that we use here in the United States specifically. One is launched, they're stationary above the equator. One is situated over the Atlantic. One is situated over the Pacific. We get a new satellite picture every 10 minutes on a routine basis. But if we request it, NOAA can actually package up the data and bring it down to a time scale of every 30 seconds. Now, when I first started my career, we could only get a picture every 30 to 45 minutes, and that was in the mid-2000s. And if I talk to my colleagues that are a retirement age, they used to get a picture 2 or 3 times a day. So the reason I'm bringing this up is look how much technology has advanced. This is incredible. But also, when we think of records, remember the data we're getting today compared to the data that we used to have 30, 40, 50 years ago. It's really hard to compare things because we're not on the same platforms anymore. We still fly airplanes, as Emily told you, into hurricanes. There are 2 fleets that do it. So NOAA has a crew. That's the crew down here on the lower left. And they fly out of Lakeland, Florida. They are research oriented. The Hurricane Center can task them if needed, but we typically work with the group on the right that I'll explain in a minute. Now, the NOAA has these 2 aircrafts up here. So this is their P3 jet. This flies directly through hurricanes, typically around 10,000 feet. So that they found out through trial and error is a sweet spot. You want to get below the freezing layer, but above the most turbulent layer. And that typically happens to be at a rough altitude of around 10,000 feet. They literally fly right through it. And the picture on the right shows you what it looks like inside the eye of a hurricane. The group on the right are from the Air Force that Emily knows someone from, and they're based out of Biloxi, Mississippi. We actually work more closely with the Air Force, even though NOAA's our more direct colleagues. The Air Force are the group that does the day-to-day missions. They are officially known as the hurricane hunters because of their job helping the Hurricane Center specifically. But both crews are heroes. Both crews do amazing work. I only flew into a hurricane once. I don't want to do it again. I did get a flight into a Category 5. I got incredibly sick, so my stomach is not ready for this kind of activity. I'll say I do some joy rides, but nothing like what they do on a day-to-day mission. But we do know most of these groups, and we do work very, very closely with them. We also use models to help predict the future when it comes to hurricanes. We have to predict where the storms are going to go. We call it track. We have to predict how strong they're going to be. We call that intensity. And we have to predict how big they're going to be. Again, we call that wind radii. It's essentially size. And from those predictions, we then can get into the details about what affects people, how much rain, how strong are the winds going to be, how much coastal flooding. That's what we're really trying to pinpoint. And from that, we work closely with FEMA to then iron out evacuation zones to make sure we get people out of harm's way. And the reality is we only evacuate in the United States for one hazard. It is not for wind, and it is also not for rain. It is only for coastal flooding because those tend to be the most destructive. We do advise people, if you know you live in a flood zone, to keep that in mind, but we do not evacuate for rain-induced floods. Now, I want to show you how much better the Hurricane Center has gotten over the years. As I mentioned, we started systematically making forecasts in the 1960s. And the average error in the 1960s, and you can see the forecast time down here, this is 72 hours. Our average error was about 425 nautical miles. So if you like things in normal statute miles, which is how we all live and work, you got to multiply it by 1.1, so roughly 450. In the 70s, the errors went down just a little bit. In the 80s, a little bit more. But then you could see where technology took over. That was in the 1990s, where the errors dropped very dramatically. Our track performance improved through the 2000s, through the 2010s, and still going here into the 2020s. So lots of times we hear the Hurricane Center screws up. They got this one wrong. I always like to fall back on statistics. I'm not saying the forecast is perfect. I'm not saying it's right. But the reality is today's ability to predict is so much better than it was just a couple of decades ago. And to kind of help illustrate this another way, let's look at just one specific case study. Let's look at a 3-day prediction. Let's say our 3-day prediction in 1990 was that there was going to be a landfall spot right here near Biloxi, Mississippi. The average error in 1990 from the Hurricane Center is denoted by that blue circle, which means even though, yes, the forecast is to go to Biloxi, it could slide left and go into Houston. It could slide right and go into the Big Bend area of Florida. That's essentially our scientific abilities in 1990. But if we repeat this exact scenario and put it onto today's level of skill, it looks like that red circle. So you could see a much narrower zone. And again, mostly due to the advancements in our understandings and predominantly advancements in technology, which has helped so dramatically. So what is harder is predicting the strength of the storms. Again, intensity. You can see in the 70s and the 80s and the 90s and even the 2000s, our ability to predict intensity didn't change very much through those 4 decades. But we've just started to improve in the 2010s and continue to show advancements in the 2020s. So we're getting the hang of this problem. We're a few decades behind predicting the track or the path of the storm. But this is an area of focus, and I have a lot of interns that I work with. I tell them always to focus on predicting strength or predicting size, because this is really where the science has yet to fully evolve and mature yet. And predicting the path, we've come a really, really long way. All right, now predicting the size, this is something a lot of people don't think of. Now, hurricanes come in all different shapes and sizes. Here's 2 hurricanes that hit Florida. Charlie was a Category 4 hurricane. Wilma was a Category 3 hurricane. Both of these struck the southern half of the peninsula. And the reason I'm showing you this is they're dramatically different sizes. You know, we try to get the media to focus on storm size. And the reason that's important is because if you just look at these 2 storms and said, oh, well, they're kind of more or less the same track. And, you know, Charlie is a little stronger, so maybe the damage is going to be worse from Charlie. Definitely not. The core winds are over a very small spot. Charlie caused tornado-like damage across a portion of Florida coming through the Orlando area, kind of like that. But Wilma produced an extensive area of damage across the entire southern half of the peninsula. So we're trying to educate our core partners, in particular the media, to focus more on hazards and impacts rather than just focus on the intensity and the track. So this is a struggle that we have with the community at large, because there's a comfort with just saying, what category is it? Where is it going? And that's really not telling the whole story. All right, so what the Hurricane Center does in a nutshell is we look at all of that information and then we produce these types of predictions. Where is it going? We call it our cone graphic. What is the chances of seeing wind thresholds? We call that our wind speed probabilities. What's the time that these impacts are going to begin? Where are the warnings? Areas that could flood? How much rain could occur? We put out all of this information. We write products, we do briefings, and we try to inform our first layer, government officials, and then second layer, media, and then that eventually translates to the general public. One of the hardest parts of our job is messaging all of this. As I mentioned earlier, too much focus on the category, too much focus on the track. We really want people to focus more on impacts. For example, we had Tropical Storm Allison in 2001. This tropical storm was retired, meaning it produced so much damage, but wait a minute, it was a tropical storm. It caused 40 inches of rain over Texas, killed dozens of people, and this was what Houston looked like during a tropical storm. So we had so many people say, well, it's just a tropical storm. I'm not really going to worry about it. Again, if we can focus more on hazards and impacts, it'll keep our focus on what really matters. So let's talk briefly about something a little darker, just to kind of put this in perspective. How do people lose their lives in hurricanes? What is doing the most damage? So if we look just over the past 6 years, well, going back to 2017, about 55% of the fatalities are people that are drowning in freshwater floods, meaning rain. About 15 additional percent are people drowning in the surge, the storm surge flooding. An additional 12% are people who are at the beach and die in rip currents or high surf. The wind is only doing about 13%. So the reality is, even though we mostly focus on winds, the real truth is what's causing most of the problems are water-related impacts, including Ian, where 64 people died in that storm, 63 of them drowned. And then we have an indirect fatality problem as well, and it's much more spread out. So a lot of people think, well, a hurricane is just going to last a couple of days, but it causes so much other problems. There's electrocutions, there's people falling off their roofs, there's heat exhaustion because they happen in the summertime in the South. There's cardiac arrest. There's just a whole bunch of issues. And here's a really terrible stat, in my opinion. In the last several years, we've lost more people in hurricanes due to carbon monoxide poisoning after a storm than drowning during a storm from storm surge. So we're trying to take part of a group. We can't do it on a national level. We need people to get really out there on a local level to understand how to use your generators. And unfortunately, this is just sort of like a hidden fatality that happens during hurricanes, or really mostly after hurricanes. All right, so I got about 10 or 20 minutes left. I want to talk about the state of the global climate and where all of this fits in. So I will say that none of this is really my opinion. I'm just trying to state the consensus of where we are with the state of the climate. And I really want you to get a perspective here that this is a science view, not a political view. It's sort of a shame that on this sort of science angle, you know, the political view has sort of overtaken the general public. But this is really just the view of NOAA and NASA in particular, and then even broader views across the globe. So what you're looking at here is a temperature trace in the white line, which goes back from 1880 to about current day. And if you look at the temperature trace, you'll see it's noisy, but the general trend is up, which is why you hear of climate change, right? Temperatures are rising, and they're rising over this period of time. The anomalies are roughly about 1 degree Celsius, so 2 or 3 degrees Fahrenheit, which is notable because this is on a global basis. So that's not insignificant. Now, it's extremely well correlated to carbon dioxide emissions, which are shown here in the blue curve. And it doesn't take a scientist to realize, hey, those things kind of line up. And they absolutely do. So from a global perspective, there is obviously a correlation between increasing temperatures and man-made carbon emissions. But what does this really mean? Will it continue? And more importantly, how does this affect us as people? And this is where things get blurrier. The consensus is temperatures have been going up, and there's a correlation to CO2 emissions. So the first thing I have to do is we have to step back and compare climate and weather, because there's, you know, one of the sort of pet peeves of mine, so this is personal here, I'm going to just state that, is people not really understanding the difference. And there is a notable difference. So weather is what's happening today, next week, in a couple of weeks. That's really weather. So individual weather events, a hurricane, a tornado, a cold snap, that's weather. Climate means what's happening over a long period of time, years, and really more like decades in reality. So lots of times when over the past several years, we've seen information like this. The record warm Christmas that we had last year is due to climate change. Not last year. Last year was really cold in the East Coast, but you get what I'm saying. That Category 5 hurricane that we had is due to climate change. That severe weather that's happening across the Midwest is due to climate change. The fires in California are due to global warming or climate change. You can't say all that. That's an uninformed view. You're mixing scales that are really different. You can't conclude what global climate change is doing to individual weather episodes. There's no way to calculate that. And no scientist would ever make that conclusion. You know, well, let's just call it a scientist that knows what they're doing would ever make those conclusions. Typically, we get questions, how much is climate change contributing to the hurricane season? I have no idea. And for that matter, nobody does. There's no way to know that. Weather is random and chaotic. There could be something occurring, but my guess would be it's a small fraction. It's not dramatic. And I'll just give you some examples of this. So the headlines are scary. And, you know, like everything and you probably remember COVID, the headlines were super scary. Whatever sort of event is interesting in people's minds. So climate tipping point, rapid glacier melt, climate anxiety, extreme weather. How about climate change will kill more Italians and Greeks than Syrians? What are we talking about here? Estimated deaths in 2050? There's no way to know this stuff. And why more Italians and Greeks? This is strange. Apparently it had to do with crops, but this is a little bit ridiculous. This is just hysteria is what this is. How about global warming is already literally killing us? These are podcasts. And then on the flip side, global warming is a hoax. This is all political. None of the like many topics, the truth is in between all of this drama. Really, where this consensus of science stands right now is that global warming is happening. We see it in the records. It is man-made to a large degree. But again, what does it mean? It doesn't mean any of this. Literally, all of this is too dramatic. It's in between all of this stuff. So let me tell you how this relates to hurricanes, and then I want to pause and take some questions. So here's what we think is going to happen. This is NOAA and NASA's view. So this is not going to be, a university's view. Like MIT has a lot of climatologists. This is really just the view of NOAA and NASA. And the reason I think this is good is because NOAA and NASA are not looking for funding. So the reality is sometimes you have to chase the dollar. NOAA and NASA are not funded to do this work. We're funded to do our day-to-day operation. We believe that the amount of hurricanes and climate change, there'll be no significant change. That's our take. We think the intensity of hurricanes, there'll also be no significant change. There's some signals that it'll get stronger, meaning that the water temperatures will increase. Storms will have an opportunity to reach their more maximum potential intensity. But we know that there are more factors than just the ocean that's driving hurricane strength, like amount of moisture and wind shear. And there's an indication that those could get stronger in a warmer world. However, one thing we do feel strongly about is that even if there's not any higher number of hurricanes or not stronger hurricanes, the impacts could potentially be worse, especially from a water perspective. And let me explain why. And this is the last slide I have, and then I want to take some questions. So this view is a global view. This was published in 2019, and this was done collaboratively between NOAA and NASA. So again, this is a wide view. So this goes back from 1970 when the records were accurate. You don't want to look at a study that started in 1900 when there were just no good records. There were no satellites. Start your records when satellites were born. So if we look globally and you start at the black line, this is all tropical cyclones across the entire globe. And if you would draw a trend, it would be basically flat. What if you look at the red line? This is just the strong variety of tropical cyclones, those that have reached the title of hurricane or typhoon. And you'll also see that that trend is basically flat over the 50-year span. What if you look at the landfalls, which is what really matters? If you look at the black bars, these are the category 1s and 2s, and you can see that trend is more or less flat. And if you look at the major hurricanes, the category 3, 4s, or 5s in red, you'll also see that that trend is more or less flat. So over the past 50 years, there's really no trends in global tropical cyclones or global landfalls. But here's where the trends do start. What if we look on the right about the latitude of where the storms have reached their maximum intensity? So what I mean by this is look at a storm's life cycle and then pick out the spot, the location where it reached its peak intensity. What we notice globally is that the latitude's getting higher. Not a lot, but there's a notable trend that's up, right? And this is definitely correlated to water temperatures. Water temperatures are increasing slowly, and storms have an opportunity to live longer and get a little stronger at farther north locations. And the bottom statistic is the worst one. This is the propagation speed, meaning how fast do these storms move? And you'll notice we see a decreasing trend there, which means that storms have been moving slower over the decades. And that's something several of my friends have published as well, and probably the most troubling statistic, because if storms move slower, they have an opportunity to sit over an area for a longer period of time, produce more rain, and potentially more coastal flooding, which is probably the biggest concern because it affects impacts. So hopefully this kind of gives you the state of the science and really the consensus view of where we are. The reality is it's mixed. It's not conclusive. The world's not ending tomorrow, but is this a problem? Absolutely. This is something we need to do something about. Many cities are aware of this, especially in hurricane-prone areas. Cities like New Orleans has done a lot of work. New York City, Miami, Houston, all of these locations are aware of this. And we're working with those cities to help sort of improve their understanding and get them ready for hurricanes but on a broader sense, prepare for the future. That's all I have. I set an alarm for 10:35. It's 10:32, so I'm pretty close. Thanks for listening. I know we got about like a little less than 10 minutes, so I'd be happy to take some questions if there's any. Thank you.
Hey, John, can you hear me? It's Rob Westcott here.
Yeah, I can hear you.
Okay, great. Hey, I've always been curious. They talk about forecasts of the European model versus the US model. Can you tell us a little bit about, like, if you're the head of the North American bloc, like, why are the Europeans forecasting us, or how does that work? Or can you talk about the difference in the two?
It's a good question. So yeah, so these models are global. That's the first thing I'll state. The Europeans are not trying to do hurricanes or anything. They cover the whole globe. Hurricanes are on the globe. And same thing with the Americans. You know, we have a global model. It's called the GFS. The Europeans' global model is called the ECMWF, European Center Modeling Weather Forecasting. There's also the United Kingdoms have their own model. The Canadians have a model. The Japanese have a model. The US Navy has their own model. Over the past 6 or 7 years, the best individual model has been the European for hurricanes. I think the reason why is the Europeans do a couple things really right. So number one, they sell their model. So they're able to generate revenue and they put that money back into the model. Number two, the Europeans work together. So through the European Union, they work with the United Kingdom and France and Italy and Germany. They find the commonality, build this model, and have staff throughout those countries. So they have a lot of talented people and great technology to advance it. It doesn't work that way in the United States. The United States works alone. The United States does not charge for their model. It's available and free across the entire world. Now, the US model, I don't want to downgrade it. It's close to as good as the European model, but most times the Europeans edge it out or beat it. The good news is the Hurricane Center doesn't pay for the European model prediction. We use it. We have good relationships with the modeling centers from around the world, and we give feedback. In fact, every year we have a representative from the Hurricane Center that goes to Europe to actually talk to them and help advance them. So there's wide open doors there. And we typically beat the European model. Not saying that to brag, it's just because of strategies. Individual models don't work as well. It's like, for example, if you have a good idea and you talk to someone next to you, or maybe 5 people next to you, and you develop a consensus, that consensus typically wins out. And we take that same sort of approach with hurricane forecasting. Doesn't mean it'll win every time, but it does mean it typically performs better than any individual model. But amongst that consensus, it's undeniable that the European model is one of the best ones. Hopefully that helps.
Question from the back row. I understand what you said about models and prediction, and I think you also what you said about satellite assistance. What I haven't heard is whether or not there are any credible projects in satellite-based weather modification underway.
Oh, wow. Such a good question. So yes, there were for decades. So for example, there were attempts to sort of change weather through the 60s, 70s, and 80s. And there were lots of attempts, but there's consequences to these attempts. When you first, I'll give you one experiment that was a miserable fail. They tried to cool the ocean in a couple of spots near the United States. Of course, that has environmental considerations. But one thing you have to understand is hurricanes are really large. So economically, it's a really bad call to try to cool the ocean, just because how much can you cool it? It's going to mix and move around. It's not a shallow body of water like a lake where you can actually make progress. There's currents that are moving the waters around. Secondly, they found that it didn't really work. They also tried to put dry ice into storms to dry them out. There was an estimate that maybe that had an impact for 2 or 3 hours. And then after that, the storm just mixed it out and moistened up. These were also, when they were done, not really considered environmentally about what other problems might happen. They were literally just a focus to try to fix hurricane landfall issues. So that's long been abandoned. And the idea now is to build better construction. So in Florida, construction is great. It's great in terms of wind damage. Like my home is made of concrete. And we have impact glass. So a lot of the emphasis now has been just make things strong, build it higher. build seawalls, essentially be ready for these, because these are natural occurring things that have been going on for centuries and will continue to go on long before and after we're here. So the reality is that there's just been a shift of educating people, building better infrastructure, and not messing with Mother Nature, because there's typically consequences when you do.
How
Thanks
do
for that
you
question.
interrelate with the weathermen that give us our hurricane news?
So it depends. Yeah, like, so some of the people on TV are meteorologists, and we have a good relationship with many, especially down here in Florida and the Gulf Coast. So we go to conferences. They're actually called broadcast meteorology conferences. So we educate them there. We're teachers at those conferences. So we teach them about messaging, traps not to fall into, how to keep focus on the message, how to understand how to interpret tools. So that's typically our role with the media. And they also interview us during hurricane season. So we also, we keep tabs on all of that as well. So I should have brought up some pictures about what it looks like at the Hurricane Center. I might be able to find them if there's a minute or two. But typically, it's like a zoo there during hurricane season. We have a room that is designated just for the media, and they pour in that room and interview us, and we try to get the message out, work directly with them. In fact, our previous director is the main meteorologist at the Weather Channel. So we have a pretty good relationship with him, of course.
Just
Good
one
question.
other question on the media is, often when we listen to the media during a hurricane forecast activity, when it's approaching and so on, they'll show these different tracks, which are, I guess, based upon the different models, and they're all generally going in the same direction, but they do have some dispersion that gets refined as the forecasting continues, in real time with the forecast. I'm just curious as to, do all of those models, for example, source out of your hurricane center, or, for example, the European model that you had talked about a little previously, is that one of the ones that's included? I'm just curious about how all of those models are exercised from the point of view of displaying that on our media, when we're watching television as the hurricane is unfolding.
So yeah, they're often referred to as spaghetti models because they look like sort of lines of spaghetti, right? And those are the different modeling centers from around the world. And that's something, of course, we're looking at all of those. The great thing is the Hurricane Center beats all of those individual lines. It's not because we're geniuses, it's because of mostly strategy, as I mentioned before. The Europeans typically included on that diagram only if they're paying for it, as I mentioned earlier. The other models are free. So the Canadians, the US Navy, the Americans, they all release their models for free. So yeah, that's what you're looking on the screen. Probably the hardest thing for me to communicate about those is they move around a lot. So like on one cycle, for example, just using cities, let's say 5 days in the future, you were looking at a hurricane coming up the East Coast. They could show a landfall down near Wilmington, North Carolina, for example. And let's say that model came out at 8 a.m. That's when it was produced. Then at 2 o'clock, you're going to get another model run from the European, and it could go all the way to Long Island, for example. And then the next one after that, it might go somewhere in the middle into Virginia. So our job is to interpret this and not have these head fakes. I always call the models they're head fakes. It's uncertain information. It needs to be interpreted, and you can't just look at these things kind of blindly. We get a lot of the people in the general public that kind of just draw a middle line of those and then decide, oh, that's probably all right. But the reality is there's no real skill in doing those exercises. And then the other point is, and one of the things we educate the media about is those lines are only tracking the center. It doesn't really show you where the impacts are going to be. So it's really like a false sense of security for some people. So for example, if that line's going to Wilmington, North Carolina, as I said, there'll be impacts all the way up into to the Delmarva for a track like that. But it may not look like that to the general public because it just is a line of the center point. So that's a really good question, and something we teach every year. I kind of get exhausted by teaching that, but it's probably the number one question that we get amongst the broadcast meteorologists. It's a great question.
Yeah, just a follow-up to that, I guess, from your explanation too, I presume that the models in real time get continually fed with additional data and observations, I guess, that you all are taking from the conditions and where the path has been, and they'll change a little bit in the process. I also presume that you all, in your coordination with the other hurricane centers and the different models, are constantly trying to fine tune your models, with past history, as well as current history, if you will, as it unfolds. Is that a fair assumption?
100% true. So both of your questions are great. So the data does go into the models, and every piece of data. So for example, the weather balloons that I showed, that gets into the models. The Hurricane Hunter flights get into the models. Some of the satellite tools get into the models. The Europeans have found, and part of the reason the European model is so successful is they found ways to use the data only positively. Believe it or not, sometimes the data provides some negative bias. Let's say the data is no good. Like sometimes there'd be a ship going across the ocean. A lot of the times those ship reports are done at different height levels. You don't know what deck they're taking at. Some of them just eyeball it, believe it or not. The captain says, it looks like 50 miles an hour. They're not always sophisticated data. And it's really hard to know what it is in real time. So the Europeans have found a really good way to use quality data, get rid of the data that's less reliable, and found out to get a positive influence on the model. Your other question about advancing it's 100% true. And in the United States, we have an environment modeling center that's actually located close to you guys. It's in College Park, Maryland. And they have a staff there that advances our American modeling suite, not just for hurricanes, but also for the global weather prediction. And all of the modeling centers do that. In fact, we attend 2 or 3 modeling conferences a year. They're probably the most scientific, and I actually find them sometimes a little dull, to be perfectly honest with you, because a lot of they're more coders, for example, than meteorologists. But we really need programmers to do that kind of work. The Europeans are very sophisticated. I hope I can get to go there. I haven't been there yet and learn about some of the tools of the trade from them.
Thank you.
John, you
You're
said
welcome.
that the intensity and the size of the storm is pretty much level over the past several decades. However, the track that they're taking seems to be shifting, and they're going farther north. And in fact, it seemed like this season, more of them turned back into the ocean, back toward the east before they got to the coast of the U.S., more than they had in the past.
Yeah. So yeah, you actually got 2 good questions there. So I'll start with the second one. This year's been a great year of storms of recurving storms. Let me see if I can grab it just really quick. I know we got to go in a minute, but it might be easier for me just to show you. So here is the tracks of the storms this year. And you can see most of them ended up over the ocean. We actually have had 19 storms so far this year, but you can see the bulk of them, except for a couple, one hit Florida as a category 3, but the others have been over the ocean. And that is because of the steering currents. So we've had a pretty big troughing. This is an El Nino year. And typically in those years, we get a lot of just troughing over the United States, and it just pushes the storms out to sea, which is great. Now, if a storm forms in October, it could push it into the United States, given its placement and location relative to the trough. But generally, that's been the theme. In terms of predicting, we're starting to make advancements in predicting size and intensity, but those advancements didn't really start until about 2010. So the technology is finally catching up to allow us to do that. Predicting size and intensity is much smaller scale. So predicting track, it's large. Predicting high pressure systems and low pressure systems, they're really hundreds to thousands of miles wide. So you can resolve that. Predicting the eye wall structure is really, we're talking like tens of miles. So it's more challenging to advance that, but I think we're getting there. I would say by the time I retire, we'll be where we are for track today is where we'll be for intensity in a couple of decades. So I think, we're just a couple of decades behind.
We hear that water levels are rising because the poles are melting. Does that affect hurricanes?
So yeah, absolutely. That kind of gets into that last point I made. So when the poles melt and when the waters increase, it causes ocean expansion or sea level rise. So that's just a natural phenomenon. Here in Miami, for example, if you look at the data, and you could look at different coastlines, but I'm just familiar with where I live, the water is up about 6 inches. The base state of the ocean coastal is about 6 inches over like 3 or 4 decades. So it might not sound like a lot, but that just means the water's already this high instead of that high. So when you get a storm come on top, you have a little cushion. You've increased your base state. I think that's really the only way to look at it when it comes to hurricanes. It is why there's like king tides and other coastal flood issues that are related to that 6-inch differential. That's kind of what we've seen. And that is due to the temperature rise and the ice, the poles melting a bit. So that's why the base state is that there is a problem here. But again, it's not, we're not dying today, which is where some of the headlines are for climate change.
Is NOAA getting enough money for its geosynchronous meteorological satellite research?
Oh, well, I will tell you, NOAA has been underfunded for a long time. My opinion is my previous boss has been now promoted to heading the Weather Service, which is just one agency within NOAA. So NOAA is generally underfunded and generally understaffed, in my opinion. But we're part of the federal government, so we have struggles with funding in different years and different things, and it's one of those things where it falls on a pretty small staff, which is why we hire a lot of contractors and work with others to actually really understand things. But yes, I will say I wish I had more time to do applied research, or I wish there was more staff to actually do applied research to advance us. There just isn't enough people or enough money to go around. Good question.
Thank you, by the way, for your presentation. I thought it was excellent and, very, very pointed right there and very informative. I want to thank you so much.
Thank you. I appreciate that. I enjoyed being a part of it too. So thanks so much.
Thank you.
Thank you very much. Thank you.
Take care, everybody.